Before we can create a machine learning model, we have to transform some features, and that's exactly what we are going to do in this and the next lecture. But first of all, now it's time to separate features and labels. So we shouldn't transform the label house price because we want to forecast that prices. And therefore we select the column median house value and create a separate object and save the object in the variable label. So here we have a panda series with all house prices or values. And then we get the features by dropping the column median house value from df. Alright, now let's focus on numerical features, and in most cases it's not the best solution to keep the numerical features as they are. So typically numerical features have very different scales. And for instance, we have different scales in the columns population and median income. So here we are in the thousands, and here we are between 1 and 15. And actually many machine learning algorithms don't perform well with different scales. And there are several methods how to scale or to normalize numerical features, and all have pros and cons, and it depends on the machine learning model which method to use. And in our case, we standardize the numerical features by calculating set values. So first of all, let's have a look at the features data frame. And here we can see that in all numerical columns, we have the data type float. And therefore, we can select all columns with float with select D types. So here we only have the numerical features. And now let's import the scipy.stats as stats. So this is an extensive statistical library. And with this, we can calculate set scores. And we can do this with stats.setScore and apply set score on each and every column with apply. And we save the result in the variable feature1. So here we have now the standardized numerical features, and I don't want to go into the theory, and just want to show you the effect of calculating set scores. And first of all, we define that we want to display only 2 decimals for floats. And then for each and every column, we can actually calculate the mean and the standard deviation. And of course, we can do this with the egg method. Now here we can see that the mean value in each and every column is 0, and the standard deviation 1. And that's exactly the definition of standardizing features. So we get a mean of 0 and a standard deviation of 1. And as a consequence, all features have now the very same scale. Alright, thanks for watching, and see you also in part 2. Bye. Typically, machine learning algorithms cannot handle text data, and therefore we have to transform text or categorical data into numbers. And in our dataset, we have 2 categorical features. However, in our final model, we only use the ocean proximity feature. And first of all, let's have a look here at ocean proximity again, and also at value counts. So we have 5 different categories, and the most frequent one is lesser than 1 hour to the ocean. And now we can transform this categorical feature into numbers with so-called one-hot encoding. And for each and every category, we create a new feature or column with binary values 1 or 0. So these are also called dummy variables or dummy features. And we can create those with pd.getDummies. So this is a direct pandas method, and we pass the ocean proximity panda series and save the resulting dummies in the variable dummies. So let's simply have a look how it works. And the rationale behind this is pretty simple. So we have for each and every district and for each and every row exactly 1 time the value 1 and 4 times 0. So let's have a look at the district with index label 0. And here we have nearby. And it's no surprise that we have the value 1 in nearby and the value 0 in all of the other dummy variables. Now there's one issue that we should keep in mind. If we keep all 5 features, then 1 is actually redundant. So once we know the value in 4 columns, then we automatically know also the value in the 5th column. So if we have a look here at the first 4 columns, then we can see that we already have the value 1. And then it's pretty clear that in the last column we have the value 0, because we can only have the value 1 in exactly 1 column. So if we are working with all 5 dummy variables, so to say, we have the information twice in our data, and this can cause the so-called multi-collinearity problem. And actually some algorithms are sensitive to and can be harmed by multi-collinearity, like linear regression. And for instance, if we use a linear regression, then we should delete one feature and only use k minus 1. So in our example, 5 minus 1 is equal to 4 features. So we have to delete one of these columns here. However, when we use other models, like for instance, a random forest regression, it can be beneficial to keep all 5 or all k features in our data set. Alright, now let's go on and let's merge our features again into one features data frame. So we use pd.concat and we horizontally concatenate feature 1 with our standardized numerical features, and also here our dummies, and finally also the income category. So this is still a categorical feature that we will require in the next video. And we pass 1 to the access parameter to horizontally concatenate all 3 data frames. And we save it in the variable features. So here we have the standardized numerical columns. Then we have the dummy variables. And finally, we have also the income categories. Alright, this was feature engineering with pandas, and again, in case we are planning to create a permanently running algorithm, it definitely makes sense to use scikit-learn pre-processing pipelines and to use scikit-learn methods to engineer features. But I just want to highlight here that we can do most of the things also with pandas and other libraries like scipy.stats. Alright, thanks for watching, and see you also in the next lecture. Bye.